Acid and base strength. Um, how do we differentiate between a strong acid or a weak acid? A strong acid readily donates a proton, which means when a strong acid is dissolved in water, 100% of the acid dissociate into ions. And all these hydrogen iodide, HBr, HCl, H2SO4, and HNO3, um, hydroiodic acid, hydrobromic acid, hydrochloric acid, sulfuric acid, and nitric acid are examples of strong acids. And how do we show strong acids in terms of an equation or a reaction? So, strong acid, when dissolved in water, you show a single forward arrow. Single forward arrow means reaction is going only on the product side. All of the HCl, all the hydrogen ions present in HCl get transferred from HCl to H2O, and we have Cl minus plus H3O plus. So all the HCl breaks down to form Cl minus, and we do not have any HCl left. So that's the definition of strong acid. And again, if I label it as acid base and conjugate acid and base, so this is a strong acid and strong acid here. So HCl is forming Cl minus, that means Cl minus is a conjugate base. So strong acid always forms a weak conjugate base. You cannot form a strong base from the strong acid. Similarly, instead of strong acid, if I take a strong base, and then how are we going to define that? A strong base readily accepts a proton. Or another way of saying is a strong base, when dissolved in water, produces OH minus ion. So let's look at this reaction. For example, sodium hydroxide, when dissolved in water, produces Na plus and OH minus. This one 100% breaks down to form these ions, and no sodium hydroxide is left. This is a sodium hydroxide. It's a strong base, and after getting rid of OH minus, is 100% breaking it down, and similarly, strong base forms weak conjugate acid. Now let's talk about what's the meaning of weak acid? A weak acid less readily donates a proton. Or another way of saying is when a weak acid is dissolved in water, only a small fraction of the acid dissociates into ions. So here, let's take the example of acetic acid. Acetic acid is a weak acid. When dissolves in water, when it is only a fraction of, so when we are showing a fraction, then we put the sign. What that means? That the reaction is going in both the directions. Let me completely write down the reaction. CO3 CHO minus plus H3O plus. So this is a weak acid. Acid forms a conjugate base. So this is a conjugate base. Now, so first thing, these two arrows written here, that shows that this is a weak acid, means it is not 100% breaking down. Second thing, this unequal in length, these arrows are unequal. I'm making a small forward arrow and big backward arrow. What that means, that the equilibrium lies to the left, means your reactant is favored. You're making more reactants. So what happens when acetic acid breaks down to form acetate ions, then acetate ions start combining with H3O plus to form this. And also remember, if this is a weak acid, then its conjugate base is a little bit stronger. And you always go from stronger to the weaker side. So here, that means we can say that the weak acid is only slightly dissociated into H3O plus and acetate ions. So mostly acetic acid is still present at the equilibrium. Um, let's do a problem here. Um, let me get rid of this. Here, I'm going to write down a reaction. For example, let's say this is the reaction, hydrogen cyanide reacting with hydroxide ions to form Cn minus in H2O. Now the question is, predict the direction of equilibrium. What it means, are the reactants or the products favored? I'm drawing two arrows of the equal length, so I want to know in which direction your reaction is going more than the other one. So first, let's label them acid base. This is an acid. This is the conjugate base. This is the base. This is the conjugate acid here. Now, why SCN is an acid? Because it donates a proton to form Cn minus. And OH minus is a base accepting the proton to form water. So find out what two acids are present in this reaction, HCN and H2O. These are the two acids present here. Then find out from the chart that's given to you in the book that says the relative strength of acids and bases. Now here, and the chart basically shows the relative strength of different acids, and in that chart it says HCN is a stronger acid than H2O. Now if HCN is a stronger acid, and we know that the reaction always go from the stronger to the weaker side, that means you're going from stronger, this is the stronger side and this is the weaker side. That means reaction is going more towards in the right direction. So then what we do, we put the forward arrow bigger and backward arrow little smaller. That shows that the reaction proceeds to the right to form the weaker acid.
Made with Doodlecast Pro.